In this video, we're going to talk a little bit about vectors. Vectors are any measurement with both a magnitude and direction. An example of a vector would be 60 miles per hour south. So if you just said, I'm going 60 miles per hour, that's not a vector yet, because even though we know the magnitude, we know how many miles per hour you're going, we don't know where you're going. There's no direction to your measurement. So to make this a vector, we'll have to say you go 60 miles per hour south. An example of why this is so important is if I said two cars were going 60 miles per hour, how far apart are they after 1 hour if they started in the same place? You don't know if they're going 60 miles per hour in the same direction, in which case they would be right next to each other, there'd be no distance between them, or in different directions. So let's say it was in the opposite direction. Two cars, one car is going 60 miles per hour south, the other one is going 60 miles per hour north. Now these are two vectors, and we can answer questions about them in physics that are more useful now. Let's say they both started in the same place, and they went in opposite directions for 1 hour, south and north. I know north and south would usually be drawn this way, but for room on our board, we're going to do this. 60 miles, that's how far to go after 1 hour. So the total distance between these cars is now going to be 120 miles. How long did it take them, remember, to go that 120 miles apart? It took them 1 hour. So, from this car's perspective, this car is traveling away at 120 miles per hour. So, that's an interesting thing about vectors. Once we have vectors, we have both magnitude and direction. We can add or subtract vectors depending on if they're in the same or different direction and what they're talking about. So let's do another example. What if I said one other car was going 60 miles per hour west? Now that's going to change things a lot, because if we draw, let's say, these two cars over here, we're going to have a whole nother problem. This car is going west, this car is going south, and now, in 1 hour, how far did they go? Let's say this one went 60 miles, this one went 60 miles. How far are they apart? It's a completely different question with these two directions. Now, we would have to draw a triangle. This would be a right triangle, and we'd have a squared, b squared, c squared. Remember, if you add these two, they're equal to this. So a squared plus b squared is equal to c squared, and we'd have to solve for this side. So vectors can be added or subtracted in different ways.